Hello. So this Mathematica problem will be about the solving the second order equation using the method of undetermined coefficients. Okay, so the problem is this: solve. Let me magnify it a little bit so that you can see it easily. Solve this problem: y double prime minus y is equal to x plus sine x by the method of undetermined coefficients. Okay, so we will not use the dsolve function, so we will use the method of undetermined coefficients. So in this case I can write this equation here. Okay, so this is the equation, and then I can write it. So the equation now is in this format. So it's a characteristic equation we can write now. Okay, first step is now to find the characteristic equation. Okay, to write characteristic equation. Okay, yeah, just make it like a comment, not like a command. Okay, write characteristic equation. So you can manually write it. Okay, the characteristic equation. So maybe I put a variable characteristic equation CE is equal to m square minus 1. So this will be the characteristic equation. Now solve this characteristic equation. Solve CE with respect to m. So we will be using the solve command for this characteristic equation and execute it. So m is equal to minus 1 and m is equal to 1 are the two solutions. So after the solution of this, then we can write the general homogeneous solution. Okay, so what will be that general homogeneous solution? So we can manually write it. It will be then this. We can represent it with YH. Okay, and this will be the general homogeneous solution. So in this case, I am using a capital E for the exponential function. You can also use exp and then bracket. So, but this is also a short format. So if you can use capital E, don't use the small e. Okay, so the small e, Mathematica will not recognize small e here. And now this is the general homogeneous solution. So now the next step is the write the general form of the particular solution. Okay, write the general form of the particular solution. So Control V, and then this is the write the general form of the particular solution. So it will be, in this case, the non-homogeneous part was x plus sine x. So its particular part will be then this. So it will be yp is equal to c3x plus c4 plus c5, and I am choosing the coefficients c3 and c4 for ax plus b. Instead of ax plus b, I'm using c3 plus c4. And for cosine and sine, and for cosine and sine, for the sine x, I will use c5 cosine x plus c6 sine x. So this is the solution. After this, because we have to find the coefficients c4, c3 by the undetermined coefficients method, so we need to take the derivative of this. So take the derivative of this yp. So and you can represent this derivative of yp by yp d1. Okay, yp d1 will be equal to derivative of yp and with respect to x, yp with respect to x. So we will get this value. I made a mistake over here, so I should put the square bracket, so it will be the yp d1. Now second derivative will be yp d2, and that will be equal to the derivative of the first derivative. So yp d1, its derivative with respect to x, and close bracket, and then it will be the second derivative. So now we can input these values of the second derivative and the yp into the original equations. The original equation had the second derivative and the yp. So I will put yp d2 minus yp. So this will be the function. This will be the this will be represented by y double prime minus y. So it has to be equated to the coefficients of x plus sine x. So for this purpose, I will write an equation like this. So in this equation, you can see that I have equated this coefficient C4 with 0, okay, and then I have to, put the double ampersand sign to represent the to input the second equation. The second equation will be the coefficient of x C3, so which is equal to 1, because our original function was x plus sine x, so it is equal to 1. And the third equation is minus the coefficient of cosine x minus 2 C5. There was no cosine x term in the equation, so it is equal to 1. And then the fourth equation is also with the and sign. It is equal to this minus 2 C6. This is the coefficient of sine x, and there was a sine x term, so that is equal to 1. So in this way, I have represented these four equations, okay, and then these four equations will have four variables C3, C4, C5, and these have to be enclosed into this bracket, okay. So in this way, I will solve this. C3 is equal to minus 1, C4 is equal to 0, C5 is equal to 0, and C6 is equal to minus 1 by 2. So in this way, then I will get the solution of yp is equal to this. So yp is equal to this, okay, because in this case C4 and C5 were 0, so therefore there is no cosine x term, and there is no constant term, only the term with x with coefficient of minus 1, and the term of sine x with the coefficient of minus 1 by 2 are here. So this was the particular solution. So after this particular solution, the general solution I can represent by yg is equal to yh plus yp. Yh was the homogeneous solution which we wrote earlier. So this is the general solution. So in this general solution, now we have to find the values of C1 and C2. So for this for these values of C1 and C2, I will take this equation, and then I will copy it down, and then I will replace the values of and then what I will do is I will say that this is equal to our y of x, okay. I can represent it by yx, okay, and then I will replace y of x with 2, which was the initial value condition, y of x with 2 and x with 0, because when x was 0, y of x was 2, so I will replace it with this. So this will give us an equation c1 plus c2 is equal to 2. Next, we need to find the derivative of this, okay, because we need to also have the y prime of x, because the second condition was about the y prime of x. So for this I need to take a derivative of this. So I can take it a derivative like from here, d derivative of this with respect to x, and then I can say that this is called as the derivative of x with y of x derivative. Okay, so I can execute this command, so I get this equation now. So in this equation now I have to replace the values of yxd and x. So I have to replace these values, Control V. So x, when x was 0, the y prime of x was 3, and then I will write it like this. Okay, or maybe we can simplify it also. Simplify. So it will be like this. So now I have this one equation, and I have this other equation. Okay, so now we can solve these two equations. Solve this first equation, Control C, and then Control V. I will put double and to write the second equation, Control C, Control V, and then comma, and then I will tell that which variables I want to solve, C1 and C2. So bracket closed. So I will execute this command. C1 will be -5/4 and C2 will be 13/4. So now I can write the final solution. So the final solution will be then equal to y is equal to -5/4 e power minus x, because for e power -4 the coefficient minus x, we have chosen the coefficient as c1, so I have put the value of c1 over here. So e power x, I have chosen the coefficient c2 in the previous case, and then add the yp was the particular solution. So I will execute it. So then this is the final solution. Okay, so in this way we have used the method of undetermined coefficients to find the solution of an initial value problem.